One study design they did not cover was about agreement analysis. One they did not cover was agreement analysis. Okay, so this is my part, reliability. Okay, so let's go and talk about reliability. Okay, so basically we're talking about reliability of the test, already covered by Azma. Okay, so how we measure, there are Kappa analysis and AC1 statistics. I guarantee most of you are totally lost. You have never heard of the word AC1 statistics. Okay, okay. So let's look at Kappa analysis. So this is an example of Kappa analysis. So if you have two person, you have if you have you look at these photos of the funder's photograph by one person and he looked at it twice and he's supposed to diagnose whether there is little or no retinopathy versus moderate or severe retinopathy. Even that one person may not always be able to agree with himself. So one person look at the same photo twice. Okay, first time he may say little or no retinopathy, but afterwards he may say moderate or severe retinopathy. So when you have situation like this, then you realize that it's very hard. It's very hard to have an agreement on something that is as subjective as retinal assessment. Okay, so instead, you have to measure the agreement of the person for the first examination and second examination and see whether it is reliable or not. Okay, that one was one with himself, but let's say you have two different persons. You have two ophthalmologists. Okay, let's say we use the example Prof. Jemima and Dr. Wan Haslina, Professor Dr. Wan Haslina. So Prof. Jemima and Prof. Wan Haslina, they both look at 100 set of funders photographs and they are asked to report whether got little or no retinopathy or moderate or severe retinopathy. You will see that they even between these two clinicians there will problems of agreement, and this agreement is worse than compared to the one before with the person with himself. Okay, so looking at the data for the two clinicians looking at the 100 funders photograph, the level of agreement is quite low. Okay, why? 46 plus 32. Okay, you combine these two is 78. So 78%. So the observed agreement only 78%. Okay. So what happened now? Okay, you are supposed to come out with an expected table. So this expected table is using the same method like chi-square, angguk, geleng-geleng. So you get the sum and then you get the expected value. So you end up with values like this. So for this table, the expected value is 32.5. Here, the expected value is 25.5. So for you to get this one, you need to use the formula of the sum. Okay, okay, this one plus this one, you get this value. So this value and this value, this one and this one darab, divide by the total. Angguk, geleng-geleng. The same way I covered on Friday that day. The sum of 46 and 10, that one will be 56. So 56 times 58 divided by the total is which is 100. And then you get the 32.5. Okay. So this is the expected agreement. So expected agreement is this value 32.5 plus 18.5. So you get 51%. So you get 51%. So what are we interested in? We are interested in the kappa value. To get the kappa value, it is the observed agreement minus the expected agreement. Then you can get the agreement, the actual agreement beyond chance. The actual agreement beyond chance. Okay. So this is the expected agreement. This is the observed agreement. So observed agreement 78%, expected agreement 51%. So 78 minus 51, the difference is the actual agreement beyond chance. Okay. So you will put this value into this formula. Actual agreement beyond chance, okay, 78 minus 51, which is 27, divided by the potential agreement beyond chance. Potential agreement beyond chance, this one. Okay. 100 minus this agreement expected by chance. So we got 49. So 100 minus 51, you get 49. So that is 49. So 27 over 49 is the proportion of potential agreement beyond chance that was actually achieved for the absence little or moderate and severe retinopathy. So you get 0.551. And that from that value 0.551, you will refer to this table. So 0.551, you end up with moderate agreement between the two clinicians. That is kappa. Okay, so Alan, can we do kappa inside SPSS? Yes, we can. Okay, can you do inside SPSS? Yes, you can. Okay. Dalam SPSS ada kappa. Okay. So that is how you measure agreement for kappa. So under SPSS, you use the discrete statistics cross tab. So under choose statistics, you click on kappa, and the row and the column, as usual, you select the two variables that have the data set. And then you get the answer of the kappa value. Okay. Alright. Baru keluar kat sana. Okay. Nak demonstrate data tak jumpa lah ya. Okay, never mind. So that is for the kappa. But kappa is very much affected when you have a very low rate. If you have very low rate of then you end up with problem. So if you have a very low rate, therefore you should go for AC1 statistic. When one of the category in the agreement is low, the kappa value is will become artificially low. Baru keluar slide punya slow ya. So here you can see this one level agreement 85. This one only 5. Why? Because the disease got very few. So when you have like situation like this, you cannot use kappa because kappa will be affected by the low rate, therefore giving you low agreement level. Then you have to do AC1 statistic. And this is the formula for AC1 statistic. Complicated like hell, even worse, cannot do in SPSS. Okay, so I'm just here to introduce you to the concept of AC1 statistic. So if you have a low value of agreement in one of the cell, you cannot use kappa, you have to use AC1 statistic. Okay, here's the example given. So instead of having a kappa of only 44, 0.44, here the AC1 is higher at 0.878. Okay. Okay, that one is for categorical, yes or no. Okay. Diabetic or no diabetic, nephropathy or don't have nephropathy. However, if your data is continuous in nature, then you have to go back to two possible analysis. One is a Blunt-Altman analysis, and the other one is Cronbach alpha. Sorry, there's another one, so it's your statistic. Okay. Why can't you use PET test? Because PET test is to show, it's not a suitable test to show agreement. Okay. It's just suitable to show trend. Okay. You also cannot use correlation, since the high correlation does not imply agreement. So this one both show same level of correlation, but you can see that there is no agreement, because this one on the left side, you can see it started at the wrong point. It's not at the starting point of 0 and 0. Therefore, the one on the left do not have agreement. The one on the right side got agreement, but the value of the R is the same, 0.94. So that's why you cannot use correlation to prove agreement. But from my experience in UKM, semua orang pakai R, semua orang pakai correlation to show agreement. So whenever they come to me, I have to redo the analysis for them. Okay. So therefore, what you do, you use a Blunt-Altman plot, but there is no p-value. Okay, but there is no p-value. You just draw the map. Okay, here are the two kinds of thermometer to measure temperature. So what happened? First, we look at the values. A plus the value of A and the value of B. Value of A is for thermometer A, value of B is thermometer B. So what happens now, for every measurement, we get the sum A plus B and A minus B. So the A plus B squared and the A minus B, just to get these values. And after you get all these values, you put it into a scatter plot. And the scatter plot will look like this. Okay. You will see that some of the differences is larger than 2 standard deviation or smaller than 2 standard deviation. So those which are larger and smaller than 2 standard deviation, we consider them as do not having any agreement at all. So when you have this kind of situation, then you have issue of agreement. Okay, then you can calculate how many measures which is out of the expected range. Then you can see, you can come up with the figures, how many percent are within 2 standard deviation and how many percent are not. So, and the difference of temperature is up to 1.5 degrees Celsius. Okay, so that's when you decide for your study whether your data is okay or not. So this one is the data I had for my exercise in class, but not for today. Okay, which BP set, the electronic and the normal signal manometer, and you calculate. Okay, you're supposed to calculate and came up with all these differences. Then you come up with scatter diagram. And this was the result that I got. The good thing is 94% of the dots are within the line. Only 6% is outside of the line. Okay. So then the other way of looking at agreement is to look at the to see what is the tolerance you want to set for the differences in the two instruments. Okay, if you expect 0.1, how much is the tolerance? 0.2, and so forth. Okay. So here in this case, 87% is found to be accurate in bracket when you set a tolerance 0.5. Okay, so is it acceptable to have 13% being more than 0.5 degree of differences? So you have to decide based on your requirement. Okay, so that is Blunt-Altman. Blunt-Altman is meant for the labs or meant for when you're trying to compare two measures, whether they are in agreement or not. Last, Chrombar alpha. Okay, Chrombar alpha, you just put in the value side by side, 2 rows, 2 columns, 2 columns, all the data set are arranged in rows. Then you select Chrombar alpha. So, and especially select analyze, scale relativity analysis. Then you select alpha, then you end up with the answer Chrombar alpha. Okay, and this Chrombar alpha shows that your value is 0.9694. Okay, so Chrombar alpha is 0.9694. So the mean difference is 2.8. Mean difference SD of 7.19. And when you plot the Chrombar alpha, when you compare the Chrombar alpha versus the BA plot, you have to decide, is the Blunt-Altman plot acceptable? Or you are okay with the idea of 94% of the points are within 2 SD level. Sebab Chrombar alpha nampak tinggi, 94. And yet, the BA plot indicates, sorry, now I'm talking nonsense already. Okay, go back. So Chrombar alpha is quite high. Chrombar alpha is 0.9694. Okay, Chrombar alpha is 0.9694. The BA plot, only 94% of the points are within the plus minus 2 standard deviation. Okay, you have the 94% versus the Chrombar alpha of 0.9694. So you have to decide whether it is acceptable or not. Is the electronic BP as reliable as a mercury sphygmomanometer? So the use of which reliability test depend on the type of data being analyzed. And at the end of the day, you will require subjective judgment during the interpretation. Okay. So in summary, if you're not in radiology, if you're not in lab, this is not your problem. You can ignore this lecture. The only reason why we are putting this in here is because it is always requested for, although the target group is very small. Okay. And with that, thank you very much. I will now stop sharing. Oh, ada question lah. Oh, sorry. Yeah. Exit. And show. Oh. Kamera saja, kamera. Stop sharing. Okay. Back to you, Madam Chairperson.
Okay, actually we are above time than the target of 12:20. So from the question, probably then Prof will actually type or like answer verbally later. So I think this is the end of the statistic in research part 2. But then as per se, like what Prof Azmi was telling about your initiative to actually go to the module on MOOC and also his website. Okay, Prof. So, all right. I think there's one more question in the chat. If you don't mind, Prof, last.
There are two questions, yeah?
Two questions, yes.
Two questions.
Uh-uh.
Okay, for the scalp psoriasis, the scoring. If the scoring, when you say, I do not know the scoring for psoriasis. I know I got scalp psoriasis, but and I know my scalp psoriasis comes when I'm stressed. So I always try to avoid stress. Of course, my daughter now not happy with me, but apparently she also got scalp psoriasis. So apparently my gene continues into my children. So pity my children. Okay. Why I have problem with that? With your question, because you say you got assessment severity. If the category is only 2, good or bad, then you can use Kappa. If you got scoring method, many score, 1, 2, 3, 4, 5. So it is something like ordinal data. Then Kappa cannot be used. If you got about 3 or 4 category, 3 at the most, maybe you can use modified Kappa. They call it weighted Kappa. Okay, that allows 3 by 3. Okay, but for those yang more than 2 categories, chances are you have to go back to either Cromba Alpha or blood augment. Okay, so I'm sorry, I do not know the answer because I'm not familiar with the method, although I got scalp psoriasis. So my father had a cure for that when I was young. Kita orang botak for my primary school for 3 years. Standard 3, standard 4, standard 5. Kepala botak. So no problem. Okay. So the other question is, okay, this one is sample size. Okay, allow me to read the question. Again from anonymous. Ramai anonymous ni. Tapi nama kat sini keluar je Kahi Wong. I attempted to use your Excel and PS2 to calculate sample size for my study that use continuous data, for which I intend to convert from ordinal data to continuous data. However, in my study, there is no D value that is applicable, so I'm unsure how to fill in the standard difference or the desired, the difference desired to be detected. Okay. So on this part, you have to ask yourself, what is your objective? Is your objective trying to measure a difference between 2 groups? If you're trying to measure a difference in 2 groups, then you have a D. But if you do not have a difference, you just have the score only, one single score, and the standard deviation. Therefore, you cannot use that formula. Okay. So my suggestion to you, since this is a Likert scale-based questionnaire, chances are there is already a cut-off point already prepared. So the cut-off point is to decide whether how many are clinically sick and how many are clinically well. So based on the cut-off point of clinically sick, what is the expected rate, and use the Kirchner formula to calculate your sample size. If you want to use the score itself and the standard deviation, it is possible. You just Google for sample size based on your sample size based on your mean and the standard deviation. But a word of warning, the value tend to vary so much to the extent it become unreliable. Okay, so my suggestion first is come up with look at for the cut-off point to decide whether someone is ill or not ill. Then use Kish. If you still want to use the mean and the SD that you get from the previous study, then you enter the value into the software. Remember, when we use the standard error of mean just now, for the t-test, when I did for the PET t-test, I showed you the formula with the n there. Okay, so basically, when they calculate the n for the sample size, they use the same formula, but they reverse the formula, so that instead of asking for the t, you are asking for the n. Okay, you can find the formula online. Okay, I did not present it because I think there's a problem with the range available for that one. All right. Okay, thank you. Okay, I think everybody's happy.
All right, thank you, Prof, so much for your kind of, attendance for the 2 statistics in research, part 1, which is last Friday, and today as well. So, anything else that Prof wanted to give a 1 or 2, as this is the last one.
Okay.
Tips, probably.
Okay.
Tips, yeah.
Okay, just to help you all, drtamel.me is always there. Okay, then we have the MOOC bit.ly/fk6163 stats. Your MOOC is there, but only for the members. If you share the password with your friends, I'm sorry, we're going to kick out your friends every day. Every day we're going to go through the list and we kick out the non-paying members. Only the paying members can get. But my statistics course is free, is open to all. There is no key there. You can join that one. Okay. How about others? I already shared with you the statistics consultation appointment system, ppukam.setmore.com. Okay, so please take advantage of that. I'm retired, so I'm very sorry. I cannot entertain you all like before. Last time, my room used to become a favorite stopping by of the postgraduate student. But since I'm retired, my room is empty. So my apologies to that. And whatever it is, don't worry. JKM, any JKM lecturers are more than well equipped to answer all your questions and statistics. That is their bread and butter. So take advantage of the ppukam.setmore.com system to have consultation with JKM lecturers. Good luck to you all.
Thank you so much, Prof. So today we wrap up our module for today. So stay tuned for tomorrow, which is the module F, Postgraduate Survival Guide. And for some tips for tomorrow, there will be a talk on an overview or systematic review. So that will be very beneficial for all. And also talk from our recipient of research of the 2024. So, I mean, the 24th Medical Health and Research Week from Prof. Dr. Raja Afendi, which is publishing your work upon graduation. I think it's important. Thank you all and see you tomorrow, okay? All right.